So starting with our vectors, since we don't have any prerequisite knowledge of what vectors are, let's start from the bit. So a vector basically is a directed line segment, which means that a vector gives us a line segment with two indicated points. For example, if they say you that the given points are P and Q, which means a P and a Q, so this line segment from P to Q would be a vector. And we denote the vector from P into Q as PQ with an arrowhead on its top, which shows that the vector is a vector quantity, which means it has a unit, it has a magnitude, and a direction. So a vector holds both a magnitude and a direction. Now this shows the direction of the vector, the arrowhead on the top. The magnitude of the direction is shown by these lines in which we put the vector in. If you write it as like this, it's going to be the magnitude, and this is going to be a direction vector or a position vector or anything like that. Now, two vectors, if they are equal, they are supposed to have the same magnitude and the same direction as well, which means that if I have a parallel vector which is AB and it has the same magnitude and the same direction as well, so they'll be called our parallel equal vectors. Now, another thing that I'm going to come under the topic of vectors is your position vector, your direction vector, and other 2D, 3D vectors which we'll be doing. Now, what is a position vector? Any vector that is, for example, we've got this grid XY coordinate in which we have our A and our B. So this vector, this specific AB vector, is going to be called a position vector through which will find this AB will be a vector that will be made out of two position vectors, which means to find AB we'll have to find OB and OA. Now, what is OA here? O is the origin. Now, OA would be this vector and OB would be this vector. And in order to find AB vector, we're going to be subtracting OB from OA from OB. So we'll be finding out the direction vector from our position vectors that are OB and OA. So any vector that is with our O's, with our origin, is called the position vector. So this was a basic background of what vectors are. Now coming towards our further math topics, which is the first thing that we're going to do is our vector equation. So we've already done different equations, different things in your coordinate geometry and stuff like that. So now we're going to be doing equations for our vectors. First, we'll be doing our 2D equations. Now, vectors are both 2D and 3D. 2D vectors are going to be the vectors that are going to lie in the xy plane. So right now we're just talking about the 2D vectors in the xy coordinate. So for the 2D vector, we know, let's start from an example. So if we have this specific uh, coordinate, and this is the x-axis and the y-axis, so this is your origin, and you've got a vector that is, for example, AB. So it's going to have a position vector from O to A and from O to B. So this vector AB is going to come out from two vectors, that is OA and OB. We already know this. So if I say that my A has coordinates, let's say 6, 2, and my B has coordinates, let's say 11, 6. So I just told you that to find a direction vector that is AB, we have to find out OB minus OA. Now, how we're going to represent vectors is like this. Your OB vector will be written as 11, 6, minus your OA vector will be written as 6, 2, which would give you, by simple subtraction of the two vectors, 11 minus 6 would give you 5, and 6 minus 2 would give you 4. So your AB vector, which is your direction vector, would come out to be as 5, 4. Now you have a position vector. You have two position vectors. You've got OA position vector and you've got OB position vector. You've got two position vectors and you've also found out one direction vector. So in order to find the vector equation in 2D form, you have to know one known coordinate, which is your position vector, and one direction vector, which you find out from the two position vectors. So the vector equation becomes, the general form of the vector equation is R is equals to OA plus lambda AB, which means this R represents any coordinate that we're going to find out from our equation. This OA is going to be your position vector, any position vector. You can even use OB over here. This lambda is going to be the magnitude of your direction vector, which I'll just tell you how to find out the magnitude. And this AB would be your direction vector. Now this is the basic form or basic or the general form of the 2D vector equation. Now we know that any coordinate means that this is something that would be unknown to us. We already know that position vector is our OA or OB vector. The magnitude of the, we already know that the direction vector is the one that we found out from our position vectors. Now how to find out the magnitude of the direction vector? So to find out dimension of the magnitude of the direction vector, we know that our direction vector AB had coordinates. We found out them to be 5 and 4. So the formula for the magnitude of any vector is under root x square plus y square. And these are our x and y coordinates, which we already know. So we'll put in the coordinates and get 5 square plus 4 square, which gives us 25 plus 16 under root. So solving this, we'll get the direction vector. So this is how you're going to be finding out the direction vector for our 2D vector equation. So that was the general form of how we find out the 2D vector equation, how we write the 2D vector equation. Now coming towards our vector equation in 3D. Now when we're talking about our vector equations in 3D, the extra thing that comes here is our third coordinate axis, which means that we're not only talking about the xy plane, we're also talking about the z plane, which means that our vector is going to be lying in three planes, which is y, x, and the third coordinate, that is our the third axis, that is our z axis. So let's make a vector over here. For example, now we know that these are three planes, which means that this is one of the plane, this is the second plane, and this is the third plane. Imagine a room or a box or a cube. It's going to be having three planes or three faces. So this is how we're going to be representing our 3D vectors. Now, for example, I've got a vector AB somewhere over here. And this is obviously my origin. So to find out the vector AB, I know that we have to obviously go from OA and OB to find out AB. However, what my OA and OB, in this one, they have the three coordinates, which means they'll be having our Z coordinate as well. So for example, my A has coordinates 3, 2, and -1, and my B has coordinates 5, -3, and 8. So we know to find out a direction vector AB, we have to subtract OB from OA from OB. So OB I have 5, -3, and 8, minus the coordinates of our OA position vector, which are 3, 2, and -1. So from here I get the direction vector AB, which is going to be 2, -5, and 9. Now coming towards our vector equation, it's going to be the same as before. We have two of the position vectors, which are OA and OB, and we have our one direction vector, which is AB, which we just found out. So we said that the general equation for our the general vector equation is R is equals to OA or OB plus lambda, which is the magnitude O, sorry, the direction vector, which is AB. This is going to differ from situation to situation. Just this is just the general form in which I'm telling you how to write it. If our direction vector is AB and our position vector is OA, they can obviously change, their names will change when we'll be doing questions related to other alphabets or other vectors, obviously. So in this case, I have my AB as 2, -5, and 9. Then I have my OA as 3, 2, and -1. However, I haven't found out the magnitude of AB, which would come out to be under root. Now, in the 2D direct vectors, we said it's going to be x squared plus y squared. However, in this 3D vectors, we have the third axis as well, so it will be x squared plus y squared plus z squared. So this comes out to be under root AB 2 square plus 5 square plus 9 square. So whatever you'll get is the magnitude of your AB direction vector. So here you'll be just putting in these values, and your R and your, yeah, just your R would be unknown, which means that if you have to find out any particular vector on that line or on that vector equation, you'll be using this equation to find out that unknown. So this is how you're going to be doing your 3D vector equation.